Okay, so welcome to our next video. This is going to be the topics that are going to close out our unit. We're going to talk for a bit about something called like terms, which should be a review from 7th and 8th grade. And we're going to talk about something called simplifying expressions, right? In algebra, we're going to have to take an expression and write it in different forms as we go to solve some problems. Okay. So let's start with a definition of like terms. So you've probably heard of these before, but like terms, okay, are terms that have to have the same variable and the same exponent. So, let's just go through some examples of like terms and some not like terms. So if I have a 3x and a 4, right, this term here has an x and this has a 4. Okay, so with this term here not having an x, these are not like. Okay. 3 and 4 though, right? Neither of them has a variable. Last time I checked, we can still add and subtract those. So these are like terms, right? 3 and 4 is still 7, even in algebra. Okay. So then we get something a little bit more, algebraic looking, right? We've got 3x and 4x. Now, they have the same variables, right? Now, the question is, do they have the same exponents? And the answer is yes, right? Because this is really x to the first and an x to the first. Those are definitely like terms, which makes our life easier. Okay? Now, this next expression, you probably know right away, doesn't meet our definition, right? Because we've got an x squared here and an x to the first here. We don't write the 1, but we still know that it's x to the first power. So these are just not like terms. Not like. Okay, now if we come down here, right, 5x squared and 2x squared, they have the same exact exponent, same exact variable. So yeah, these are like terms. Okay. The next piece is one that people get wrong a lot in algebra. 3x and 2y, right? So that first part of our definition here, that they have to have the same variables, comes into play, right? Here's an x, here's a y. Sometimes we say that it's like combining apples and oranges. If you have 3 apples and 2 oranges, you don't have 5 apples or 5 oranges or 5 of each. You just can't put them together, okay? And that goes to our understanding that they're not like terms. Okay, same idea here, right? It might be tempting if I were adding these to add up my 3 and my 2 and get a 5. But I really can't do that, right? So if I go to combine them, I'm not allowed to do that. Those are not like terms. Okay, and I think it's possibly worth showing here. Let's move this over. Actually, let's just move it out of there. We're going to fill this back in. And then I want to show you, why some of this works here. So let's say that we have the expression. We have the expression 2x plus 5, right? Now, we might be tempted, and this is not correct, okay? We might be tempted to say, oh, 2x plus 5 more is 7. Well, is 7x. Sorry about that. But let's take a look, right? So if these are the same expressions here, they should have the same value. Well, let's say now that x equals 4, right? Well, this expression then becomes 2 times 4 is 8, plus 5 is 13. Okay? This expression, 7 times 4, is 28. So we can clearly see from this that 2x's plus 5 does not equal 7x. Okay? So that kind of underlies what we're doing next, which is taking expressions and simplifying them, right? So our rule for simplifying expressions is, when I'm going to simplify expressions, right, with adding and subtracting only like terms can be combined. okay? So as I look at this expression here, I see 4 terms. I see a 3x. Now this is tricky, but I see a negative 4x. I see a 12, and I see a negative 7. So I can combine these, right? These are like terms. So 3x minus 4x gives me negative 1x, okay? And then these terms are also like terms. So I can put together my positive 12 and my negative 7. Positive 12 and negative 7 makes a positive 5. Now I can't take the negative 1x and the 5 and put them together because they're just not like terms. So this is simplified. There's nothing else I can do with that expression. Okay? So this next one here, right? Now they're out of order, but you know, knowing that I can add and subtract I can add in any order, I see an x and a 5x. Okay? So this is important. Sorry about the confusion here. This is important, right? In algebra, I have to understand that this x here is really a 1x, right? I have an x, that means I have 1x. So I have 1x and 5x combined to give me 6 x's, okay? And then I have a positive 2y and a negative 1y, right? I'm going to put those together, giving me 2 minus 1 minus 1y, which I'm just going to write as y. All right, so let's do one more example, and then you should be all set to start with your practice problems. This one now has a bunch of terms. Let's see, does x squared have a term that's like it? Yes, it does. I have an x squared plus another x squared. Now, when I add these, right, I have 1x squared plus 1x squared is just 2x squareds, right? I'm not going to change that. I know it's tempting to add the 2 and the 2 and make 4, but I can't do that. All right, the next set of like terms, I've got a negative 3 and a negative 1. Okay, so negative 3 minus 1 is negative 4x. Okay? When I'm going to simplify an expression, I have to keep in mind, right? This looks like a minus, and it is. But I can treat this whole thing as a negative 3x, and that makes it easier to simplify. And then the last set of terms, a positive 12 and a negative 10, gives me 12 minus 10 is positive 2. Okay? Now, I can't put together an x squared and an x. I can't put together an x and just a regular number. So this is it. Okay? This is my simplified expression. Okay? And as we go through the year, we're going to spend a lot of time simplifying complex expressions and equations, which are going to be helpful in problem solving. In order to do that, you need to really have a strong understanding of what like terms are and how to combine them. So go ahead and try those practice problems as part of your homework, and I'll see you next time.